Hello everyone, this is Bowen, and I would like to introduce you guys to a language checker project, WordChecker. The goal is to design and implement an efficient checker for correct language usage. We are using Ngram model and hash map as data structure. For reference, we consulted the speech and language processing book. For specific details about our project, please visit our repo. The performance of our data training process is about 1 hour per gig of training. We trained over 2 gigabyte of data set. Analytically speaking, our time and the space complexity is about big O of n. Now let's take a look at our GUI. Up here is the inputting text box where you can say this is a strange word, and you say word check, and we can see this so is being highlighted for incorrect use of a grammar. We could also use the speech input. This is a strange word. And we release the button, and well, my language is not that perfect, so it will still highlight the incorrect grammar. Now let's go see the command line UI. By saying dash help, we'll be able to see all the available command that we can do. And let's just check a file called dash file and then called test2.txt, and then we can see all the problem words are being highlighted. Thank you.
In the heart of our language checker, we used Ngrams, but before going into the explanation of what Ngrams is all about, we'll set some notations clear. Right? Capital W denotes the sequence of words that we see in our training data set, W1 to Wn, where n can be any natural number. What we are trying to model here is the joint probability of the word sequence that we have seen in our training data set, which can be split into these conditional probabilities by product rule of probability. If you look closely in each of these terms, the probability of a particular word occurring depends on all the words that have occurred before that word. So what Ngrams does is that it essentially approximates this conditional probabilities into these forms. What it essentially does is it does not consider all the words that has occurred before that word, but only a single word in case of bigram, but two words in case of trigrams, and 3 words in case of 4grams. During training part, we essentially calculate all of these probabilities and storing it. And when a new test sentence comes in, which is in the form WS1 to WSM, which is the M is the length of the sentence, and we are just essentially calculating the probability of that particular sentence by using the probability values that we have calculated during the training part. But the problem with this Ngrams models is that when we don't have a word that occurred in our test sentence, which did not appear in the training data set, that means this probability of the whole sentence goes to 0. To avoid the problem of a test sentence probability becoming 0, we used smoothing techniques. One of the techniques that we used is Laplace smoothing, where you just add 1 to each of the word combinations that is appearing in our test sentence. For example, if I love apples is the test sentence that we are dealing with, and each entries in this matrix corresponds to each of the row word occurring before the column word, and we add 1 to each of the entries in this table, and that is as simple as that. That is Laplace smoothing, and the data structures that we use for this Ngrams will be explained by Al.
Hello guys, we use 4grams in our implementation, and here are the data structures we use in our model. Firstly, we started with Ngrams matrix. That's a 2D matrix. Every word corresponds to in our columns, and the rows are determined by whether you're using bigrams or trigrams. If this is the sentence, that is the equivalent to bigrams matrix for it. For example, this is one because WordCheck word is followed by is 1 times. As you can see, this is a sparse matrix, and the memory consumption is huge. That is directly corresponds to the application size, which is also big, and loading time, it takes more time. That's why we tried hash map data structure. Our data structure is hash map of string of hash maps, which is again hash map of string of integers. If this is our sentence, by the way, I want to make a point. those two sentences are equivalent in our model because we are ignoring punctuation and we are ignoring in a word that doesn't have A to Z or capital A to Z and primes. And we are storing it something like that. This corresponds to start and this corresponds to end. This is our dictionary we are storing in 4 grams. You can pause the video and look at the details of it. Apart from this hash map, we furthermore improved it by ignoring the combinations that has less than 3 occurrences to improve our storage. And we also trained with hash set instead of hash maps. It didn't give a big improvement. We also tried with tries. This is a generic try implementation. It has try array list here, as you can imagine. But it took more memory than hash maps, so that we adapted hash map implementation. We also did, instead of arrays, hash maps. It didn't do that memory consumption. So this is our overall final model we use in our foregrounds.
Hello everyone, I'm Ming. I'm going to talk about the web scraper of our language check model. So the web scraper is actually where the dataset comes from. To train and testing our model, we scraped from Gutenberg, Google, and Twitter. So let's see how does it work. This is how we get data from Google to extract HTML and convert the contents to text file from websites. To do this, we are using a library called JSoup. In our code, if you give a keyword like here, it will search for this keyword and we pick 100 links and download the HTML and then parse the text content and save it to text file. So this is the result of this code. To download data from Twitter, we are using Twitter 4J library and then create a usable configuration, and similar to Google Scraper, we just type the keyword and run this code. We can get the tweets as a JSON file, and then we can easily extract the text part from that file.
Hi, so I'm Prateek, and I'll be talking about the Android application which I've made. It is based on the same Ngram model which we have spoken about. So here we use a smaller version of the Ngram model since the entire model could not be run on the RAM which is available on the normal phones. So if you come into the application, we have two main Java classes. One is main activity where the entire thing starts off. I have like two main things going on. One is Google Speech API, which turns the speech into text, and the text part where we can enter anything and we can give it to the Ngram part. The second is the display message activity where the message goes in and the Ngram model actually kicks off. It starts evaluating and then we have a displayed message which is same, but there is certain highlighted part which is wrong, or it could have the same thing. So this is where the designing part happens. So as you can see that this is the main layout and this is the layout which I can work upon. I can edit, I can write anything I want, and I can adjust the buttons and everything. So let's test it out. So as you can see here, as soon as I connected and I run, I click the run button, this popped up. It takes around 1 minute to load the model because the size is a little big. As you can see here, you can see the entire log which happens. If I touch, it would move and it would record the entire thing which is going on. Now as far as the UI is concerned, I have two things. One is tap for the mic and I can type the sentence here. Let's test it out. Suppose I go to the office, right? So it has some mistake here, and when I do check now, it should point out the go is highlighted. That means that is something wrong which I need to improve. Now similarly for the Google Speech part, this is the button where I click. Now as soon as I click it, I would record something and then it would give me the result of it, whether right or wrong. Let's try it out. I go to the office. So as you can see, as I said, I go to the office, go is wrong, and that's highlighted, and that's all about it. Thank you.
As you can see from the demo, this is how we implemented our project. We tried our best to complete this project. We implemented command line interface, graphical user interface, Android client, and ability to give feedback in Spanish, which we cannot really talk in that language. Overall, the project can be improved. We thank you your time, and it was a really great and educative process for us to deal with this project. Teşekkürler.
Namaste. Namaste.
complete this project. Why are you laughing?